Hey, welcome back. So this is the review for test 1 in Math 1620. So let me give you sort of the question pool, and I'll be taking questions from my math lab. So 8, questions 1, 2, 4, 6 to 8, 10, 11, 5.9, 1 to 3, 5 to 8, 6.1, anything 1 to 11, 6.2, anything 1 to 11, 6.3, 1 to 12, 6.4, 3 to 6, 6.5, anything from 1 to 10. Okay. So I would go back and make sure I could handle any of those problems. For example, I got it open. So what I'm going to do is just go through and pick and choose some problems here for our review video. Okay, so starting way back in 5.7, we had the natural log rule for integrals. So the integral of 1 over x dx is the ln of the absolute value of x plus c. Okay. So for example, number 3, we had something like 2x squared plus 8x minus 8 over x minus 2 dx. So I would expect you to be doing long division on this problem. So x minus 2 into 2x squared plus 8x minus 2. So what times x gives me 2x squared? So say 2. So I get 2x squared minus 4. 2x, that is. So 2x squared minus 4x. And then I subtract this. So I get 8, 9, 10, 11, 12x. And then bring down the minus 2. Then what times x is 12x? So 12. So I have 12x minus 24. Subtract those characters. Looks like I got 22 left. So I use that information to rewrite my integral. So it will become 2x plus 12 plus, so it's always this kind of, somebody in my office hours? Oh, hello? Oh, hi. Somebody's in my office, sorry. And then, yeah, so it's this counterclockwise thing. So you're going 2x plus 12 plus 22 all over the x minus 2. Okay. And then that's dx. So the first two terms, those are just business as usual. So power rule on the first guy, 2x squared over 2 is just x squared. Integral of a constant is the constant times x. And then this last guy, you can do a u sub if you want to. It's not really necessary because there's no term in front of the x. You see, if you did a u sub for the denominator there, the x minus 2, the du would be dx. And there's no constant that's going to float out of the integral. So anyways, you get x squared plus 12x plus 22 ln absolute value of u if you want. So let me do the nitty and gritty work here. So the integral, if I did the u sub, it'd be 1 over u du. And then x squared plus 12x plus 22 ln absolute value of u plus c, and then you're back subbing, and then you're done. Absolute value x minus 2 plus c. Okay, great. Yeah, so long division there. Let's see what else. Is anything else interesting? Not really. Let's try number 11 and see how that one pans out. So 11, we have the integral of e to the negative 7x tan of e to the negative 7x and then dx. Looks like you could do a u sub right off the bat for e to the negative 7x. Du then would be e to the negative 7x times negative 7 for the chain rule dx. And then I'm going to divide out, solve for dx. So dx would end up being negative du all over e to the negative 7x. Then I'm going to back sub that into my integral. So I'll have e to the negative 7x times tan of u times dx, which is negative du all over e to the negative 7x, which will equal, so those guys are gone, I lost my 7 somewhere. There he is. So that would be negative 1/7 integral of tan of u. And I really should have checked my answer back there. Let's check that one answer at least. Make sure I'm not misleading anyone. X squared plus 12x plus 22 ln. And then we need like absolute value symbols. Ln of x minus 2, and then plus your big C. I just want to check and make sure it's right. Oh, it's wrong. I must have done something wrong. X minus 2. Oh, I see what the mistake I did already. So it's right here. Should have been an 8, so bring down an 8 here, and then that would be 16 here. So this would be 16. Sorry, this is why I checked. 16, 16, and then 16, and then hopefully that's it. Submit, whatever it does. Okay. All right. Where was I? Okay, so negative 1/7 tan of u du. If you don't remember the formula for tan u, what you have to do is just rewrite it as sine u over cosine u, and then do a u sub for that cosine. So, or a z sub, I guess in this case. So cosine u dz, the negative sine u du. So du is going to be negative dz all over sine of u, and then you can rewrite this, so this little integral over here to the left, rewrite it integral negative, pull out 1 all over u times, or 1 over z, I guess in this case, times dz, and then that would be negative ln absolute value of z, but that would be cosine of u. You can bring the negative inside here and rewrite it as ln of 1 over cosine, which is really just secant. Right, so this would be the negative 1/7 ln of the absolute value of secant of u, and that u value is e to the negative 7x, okay, and then plus your integration constant. So let's see if that's what they want. Negative 1/7 ln absolute value secant of e to the negative 7x, and then plus your integration constant. And that should hopefully do it. Yeah. Okay. Okay. So great. So let's move on to 5.8. So 5.8. We get the inverse tangent formulas, the inverse sine formula. So you have to have those two formulas memorized. I'm not going to put any, arc secant or arc anything else on there, arc cosecant. But arc tan and arc sines are fair game. So integral of, and that's why if you look back at my 5.8 question pool, you don't see every problem. I'm trying to avoid the ones that would be arc secants or arc cosecants. So anyways, 5.8, you have to have the formulas memorized for arc tan, which will be 1 all over a tan inverse of u all over a plus c, and then du all over the square root of a squared minus u squared would give you the arc secant, or arc sine, sine inverse of u all over a plus c. So you have to have those memorized. Let's go ahead and do assignments here. 5.8. I just want to pick 1 or 2 of these, check them out. So let's look at, is 5 fair game? No. Let's look at 6. So from 6, I have the integral of secant squared x all over the square root of 49 minus tan squared x. So this is one of those ones where you're going to have to do a u sub to get it into the form, and of course the form looks like a a sine inverse, right? So let u be tan of x, and then the derivative of u, of course, is secant squared x. So you need to have all the basic derivatives memorized. Dx is going to then be du all over secant squared x, and then I can do my subs here. So I have secant squared x all over the square root of 49 minus u squared, and then times du all over secant squared x, and it looks like our a value will be 7. So du over the square root of 49 minus u squared equals sine inverse of u all over 7 plus c. So back subbing, you get sine inverse of tangent x all over 7 and then plus c. So let's see if that works for us. I bet you they have a, which one of these, sine inverse, and then tan x all over 7 and then plus our integration constant. Yay. All right, so those, looks like number 8 is then kind of the same idea, except that then we have to evaluate. So we get like pi over 4 to pi of sine x all over 1 plus cosine squared x dx. So let u equal the cosine x this time, and then du is negative sine x dx. So dx is negative du all over sine x. And then I'm going to integrate, I have sine x all over 1 plus u squared times negative du all over sine x. Remove the sine x's. I have a negative integral du all over 1 plus u squared. So that would be negative. A is 1, so 1 over 1, and then tan inverse of u. U is cosine x, so just back subbing all at once. And then I need to remind myself to evaluate from pi over 4 to pi. Okay, so I end up with negative tan inverse of cosine of pi is negative 1, and then minus will become plus tan inverse of cosine of pi over 4, which would be root 2 over 2. So tan inverse negative 1. So I'm not sure how I would even do that with my range for tan inverse. It's not in the range. Let's think about this. It's an odd function, so I could probably just rewrite this as negative tan inverse, bring the negative out. That would become positive, so tan inverse of 1. And that would be pi over 4. And then tan inverse of this 1 over root 2, which I have no idea what that is. So I'm going to have to go to my calculator. And it wants 3 decimal places. So make sure I'm in radians. And I'm just going to go with negative tan inverse of negative 1. Maybe the calculator won't like that, we'll see. Plus tan inverse of square root 2 over 2. Oh, calculator's happy with it. So 1.400, 3 decimals, 1.401. 401. Let's see what the answer. Yay! Okay. Well, that one at the bottom looks. Make sure you know how to complete the square on these problems. Let's zoom into the next section. Okay. So some of these, remember, you have to complete the square, and then you can do your U sub. Let's go to 5.9. So 5.9 was on hyperbolics. And in particular, I'm not going to worry about the inverse hyperbolics. Those, I would give you a table if I wanted you to figure those out. But the regular hyperbolics are pretty simple, so long as you remember that they act just like the trig functions, right? Kind of. It's just the signs are a little different when you take derivatives. Okay, so anyways, let's take a look at a couple of those. It's just a simple one here, number 5. So I expect you to be able to do integrals of hyperbolics and derivatives of hyperbolics. You're going to need a u sub on this guy. Minus 2x du is negative 2 dx, and then dx is negative du over 2. That would be the integral of the sinh of u times negative du over 2. Factor out the negative 1/2, then you got the sinh u du, and then integrate that guy. So negative 1/2 integral of sinh is cosh of u, and let's back sub while we're at it, and then plus your integration constant. So let's see if that's right. Cosh of 1 minus 2x plus c. Yeah, no, yes, okay, that was good. Let's make sure we can do some derivatives. Did I assign any derivatives in the homework? Didn't even look at. Okay, so there's a nasty one there. Let's try number 3. So I have g of x equals secant, hyperbolic secant of 2x squared. So this is kind of like 3 functions for the price of 1. The innermost function is 2x, the next level secant of that, and then the next level, which I'll call the g of x, is v squared. Okay? To get the derivative, all you have to do is take the derivative of these guys and take the product of them. Okay, so g prime of x is going to be 2v times hyperbolic secant. The derivative is negative hyperbolic secant of u, hyperbolic tan of u, and then times the derivative of 2x is 2. And then you just start back subbing, and you should be good. So I have 2 times v, which is hyperbolic secant of u, and then that mass hyperbolic secant u, hyperbolic tan u, and then times 2. Let's put the 2 up front, so I got a 4 here. Bring the negative up front as well, so negative 4 hyperbolic secant squared of u, which is 2x, and then hyperbolic tan of u, which is 2x. And that should be your answer. Okay, so be able to do the derivatives, and if you need to work on some more, go to the book and look for problems in that region. You can see what number of problems these are. This is 5. This problem here is problem 34 in the book. So all you'd have to do is kind of go to your ebook. Let's go to the ebook real quick and see if we can't find it. There we are. So ebook, and then hit 5.9. 5.9 maybe. Exercises, and just look around for derivative problems, finding derivatives. So these problems in here, you should be able to handle these. If you want some more practice, there they are. Okay. Alrighty then. Let's skip ahead then to 6.1. So 6.1, we began looking at differential equations. We want to be able to check whether or not a given solution is a solution to a differential equation. Does it satisfy the equation? And then just using integration to solve a differential equation. I'm not going to put Euler's method or slope fields on the test. So anyways, let's look at number 1. Where we're checking a solution to see if it works. They give you a differential equation, fourth derivative of y minus 81y equals 0. Check to see whether y equals 6 cosine of 3x is a solution. So the way you do this is you're allowed to use this as your given information, this y function here. You're also allowed to manipulate it algebraically or calculusly. So you could take its derivatives, right? So I can get y prime is negative 18 sine of 3x. Y double prime is negative 54 sine 3x. And then y triple prime is going to be, let's just get the calculator out. 54 times 3 is 162. Whoops, this should be cosine now. And then this would be positive 162 cosine of 3x. And then the fourth derivative is 3 times 162. 486, 86 cosine of 3x. Okay, great. So what you want to do is substitute this information into one side of the differential equation and then make simplifications and do algebra until you get to the other side. Okay, so it's like building a tunnel from one side to the other. So what I would do is note the side you're starting on. So I'm going to start on the left-hand side, substitute. So I'm putting in this fourth derivative for y to the fourth, or that's what that parentheses 4 means. Instead of using Roman numerals, they'll start going parentheses 4, parentheses 5, just in case you don't know the Roman numerals. So you get 486 cosine of 3x, and then minus 81 times y, and y is in our given box right there as 6 cosine of 3x. And then do a little bit of arithmetic. 81 times 6, I'm presuming, is 486 cosine of 3x. And of course, then that equals 0. And you see we started on this side and we ended on this side, which is what we want. Okay, so that shows that the given function satisfies the differential equation. So I would say yes. But you have to show me the work on the test. You can't just say yes. You have to go through that, get the derivatives, plug it in, get from the left side to the right side. Okay. All right, let's look at maybe some of these where you have to integrate to get your answer. Let's try number 9. So dy all over dx equals e to the x all over 5 plus e to the x. Okay, so the solution is just the integral of this right-hand side. So e to the x all over 5 plus e to the x. This guy, you can probably do a u sub on the denominator. So du is going to be e to the x dx. And of course, dx is du over e to the x. So integral e to the x over u times du all over e to the x. Cancel. Integral du over u equals ln absolute value of u plus c. Back subbing. So we can handle that. Hopefully ln, let's see if it allows me to type in absolute values. Using the GUI buttons over there just are annoying. So plus c. Did we get it? Yay. All right, so that's 6.1. 6.2, I think that's where we introduce exponential growth and exponential decay. So you have to have the formula memorized, y equals ce to the kt, just in case I ask you something along those lines. So let's look at 6.2. I can find my assignments. Okay, so 6.2, you see more. Okay, so in the beginning, they do a little bit more with using integration to find the solution. But I guess at the point, they had to introduce separation of variables a little bit, or they couldn't really do any of the integration problems, any of the differential equation problems. So there's a little bit of separation of variables right here. So you should be able to handle these. Let's move ahead to more of the story problems though. So number 8, they're giving you some information. You basically have to fill in the blanks. So that you have plutonium 239, half-life, so this is the isotope. Half-life is 24,100. The initial quantity, so I'll just say T is 0, is unknown. T at 1,000 is unknown, and then T at 10,000, well actually 11,000, is 1.9 grams. Okay, so fill in the chart. You don't need to reestablish the formula. You just have that kind of memorized. Y equals C to the KT. You want to find K, you want to find C. So I'll begin with just finding K using the half-life. So basically 1/2 of C will be left over in 24,100 years, and that will allow you to solve for K. So divide both sides by C, you get 1/2 equals e to the 24,100 K, ln on both sides. That will tell you that ln of 1/2 is equal to 24,100 K. Divide both sides by 24,100. 1/2 all over 24,100. I'm not going to round. I don't know why they. Because it's never clear. Do they mean round at the end, or do they mean round in the middle of the problem? I'm not sure, but I'm going to round at the end. So anyways, what do I have? I have y equals ce to the ln of 1/2 all over 24,100 times t. Then I'm going to use this other initial condition, so to speak, that there's 1.9 grams left when t is 11,000. So you have ce to the ln of 1/2 all over 24,100 times 11,000. Okay. Solving for c, you get c is 1.9 all over e to the ln of 1/2, and I'm going to get an approximation now, 24,100 times 11,000. Okay, so let's take a look at that. Escape 1.9 divided by e to the second ln of 1 over 2 divided by 24,100 times 11000 in parentheses. Make sure I got my parentheses right. That's okay. And I'm getting 2.60. I'm going to go to 4 decimals, 607.1. So then they want, what do they want? The initial quantity. I guess that's what I just found. So they want 3 decimals. 2.607. 3 decimal. Yeah. Okay. Then the amount after 1,000 years. So you just rewrite your equation. 2.607 e to the ln of 1/2 all over 24,100 times 1,000. And that should give you it. So I'm just going to use the answer that's stored in my calculator. That way I don't have to approximate times. I won't take off if you approximate, if your approximation's a little off. That doesn't bother me here. It could bother you in the real world, right? If you're doing some sort of satellite landing on Mars and you don't carry the right number of decimals, it could really screw things up. Here it's a safe place. You don't have to worry that much. Okay, so it's looking like it's barely gone down at all at this point. So it's about 2.533. 2.533. And hopefully that's close enough. Yay. Okay. So probably something like that. Let's move on then to 6.3. I think 6.3 then was probably getting into separation of variables. Let's see. Yeah. So let's look at number 2. So we have 2x squared plus 7y dy all over dx equals 0. Separate. So I'm going to move the 2x squared to the other side. I got negative 2x squared. I like to keep all my constants on the right. So I'm going to divide both sides by 7. Then I'm going to go ahead and multiply by the dx. Then you integrate both sides. Negative 2 over 21x cubed plus c. It's better not to get an explicit solution here. Just leave it implicit. You can multiply by 42 if you want. So you end up with 2y squared. Move the x stuff to the other side. So sorry, so this would have been 21 if I multiplied by 42. Right? And then this would be 4x cubed, and then c over there. So let's see if that works. 4x cubed plus 21y squared equals c. Okay. So be able to handle any of those. Let's see, so be able to do the initial condition problems. So let's try number 8. We have y prime minus 2e to the x equals 0, and y of 0 is 5. So separate, so move the 2e to the x to the other side. Get your dy dx separated. Integrate both sides. Not much to do there. I'm going to multiply by 2 and just leave it in this implicit form. Then use the initial condition. So y of 0 is 5. Plug 5 in. 25 equals 4. E to the 0 is just 1. So 4 times 1 is 4 plus c. So c is going to be 21. So your answer, y squared equals 4e to the x plus 21. Let's see if it's happy about that. So y squared equals 4e to the x plus 21. And let's see how that goes. Okay, this looks good. Some harder ones here and here. I'm not going to put the orthogonal stuff on there. You don't have to worry about that. Let's move on to, what's next? I think we just said this was 6.2. Or no, this was 6.3 here that I just did. This was 6.3. Let's try 6.4 then. So I believe the 6.4 is on the logistic differential equations. So you need to have that logistic differential equation kind of memorized. It's a lot like the exponential one. So the exponential one, if you remember, is dy all over dt equals k times y, right? For the logistic differential equation, then you just tack on an extra factor of 1 minus y over L. Okay? So you need to have that form memorized. It's probably a good idea to have this also. Y equals L all over 1 plus e to the negative be to the negative kt. Okay. Let's take a look at the problems though, before we get too carried away. I can kind of zone in on what you need, which one do you need memorized. 6.4-ish. 6.4, there's only like 4 types of problems in here that I would even, like number 4. Okay, so you know, you definitely need to have this memorized in order to pull off problem 4. So memorize this. You don't necessarily need to memorize this, but you need to know, you need to be able to ID all the parts, right? Because that first question in part A, look what they're asking. Use the equation to find the value of k. So if you don't know which part is where, you're probably going to get that wrong. The k is the k is in the exponent of the e, and it's not, it's, you take the negative of it. So if you see negative 0.4 here, it's just the 0.4 part that's the k value. Okay, so 0.4. The L value is always in the top, so it'd be 3,400 is L. Find the initial population, so you're just plugging in 0 for t. So y of 0 would be 3,400 all over 1 plus 33. E to the 0 is just 1, so 3,400 all over 34 is just going to be 100. Part D, use the equation to determine when the population will reach 50% of. So that guy is just a pre-calc problem, right? So you're just taking the initial population. They want to know when we're at, no, sorry, the carrying capacity, when you're at 50% of the carrying capacity. So you're looking at half of 3,400. That's 1/2 of, or 50% of the carrying capacity. And then setting that equal to the original logistic equation. And then solving for your t. Okay, so you can kind of cross multiply, but really you're multiplying both sides by 1 plus 33 e to negative 0.4 t, dividing both sides by 3,400 over 2. So that ended up giving you 2 on the right side after all is said and done. So you get 33 e to negative 0.4 t equals 1. E to negative 0.4 t equals 1 over 33. And then ln it on both sides to unlock the exponent. Negative 0.4 t is ln of 133. Then divide both sides by negative 0.4. 33 divided by 0.4, and plot that into your calculator for an approximation. Need some light. So negative second ln, clear, negative second ln of 1 over 33 divided by 0.4 is 8.74-ish. They want 4 decimals, so 8.7413. Then finally, the last part is what you need. You need the differential. You need to memorize this form because they want the formula, right? So in terms of p, dp over dt equals k, which is 0.4 times p times 1 minus y, or in this case is p, all over L, which is 3,400. Okay. So in order to answer that one part of the question, you need to know that. You know, you'll lose maybe 2 points if you don't do that on the test. So just do damage control if you're feeling overwhelmed. You know, think about getting as many points possible. Okay, so that's 6.4. 6.5 then is linear equations, linear first order differential equations with the integrating factor. So let's look at 6.5. And right, so let's look at number 2, I guess. We have y plus 163 cosine x dx minus dy equals 0. So the deal with these, first you got to get it in the appropriate form. So if you've forgotten the form, it's always y prime plus p of x y equals some q of x. Okay. So I'm going to need to do some division. First off, I'm going to divide by dx. So I'll have y plus 163 cosine x minus dy over dx equals 0. Then I'm going to distribute this stuff. Okay, so I got y cosine x plus 163 cosine x. I'm going to move you know, the dy over dx to the other side. I'm going to flip-flop the sides. Move the y cosine x to the other side, so minus cosine x times y, just putting it in our form, equals 163 cosine x. Okay, so now it's in the sort of standard form for linear differentials, linear first order differential equations. Then I'm going to take my build my mu value, which will be e to the integral of p of x. In this case, p of x is the negative cosine x. So the integral of negative cosine is going to be negative sine x. And then multiply by the integrating factor. So you get e to negative sine x y prime minus e to the negative sine x cosine x times y equals 163 cosine x e to the negative sine x. Okay. The left-hand side will collapse into the derivative with respect to x of y times mu. Then the right-hand side, we're just stuck with what we have. I integrate both sides, so on the left, the integral and the derivative go away. On the right, you got 163 you could factor out. Then you could do a u sub for the sine x here. Let me do that to the left. So du is going to be negative cosine x dx, and then dx is going to be negative du all over cosine x. So I have then cosine x e to the u times negative du all over cosine x. These cosine x's cancel. You can bring on a negative. Y e to the negative sine x equals negative 163. It'll be integral of e to the u, which is just e to the u, and let's back sub the negative sine x up there, and then plus your integration constant. I want to divide by y, divide by e to the negative sine x, so I get y equals negative 163 plus c over e to the negative sine x, or if you'd rather, c e to the positive sine x. Okay. That was a long one. Y equals, oops, they already gave me the equals, so negative 163 plus big C e to the sine x. Let's see if it's happy. Okay, we're good. Okay, so be able to do those. They also have initial condition problems. Let's try number 9. Oh, let's try number 8. Number 8 looks a little harder than what I would put on the test, but we'll take a look anyways. X plus 5 cosine x. So this time initial condition. So you have to solve out for the c value. Okay. There's no video quiz in these review videos, in case you're wondering. Anyways, this thing is already in our appropriate form. So mu is e to the integral of tan x dx. The integral of tan x, if you remember, is ln of the absolute value of secant x. We could throw out the absolute value because of the initial condition here. Secant of 0 is 1, and 1 is positive. So, you know, you could rewrite this as e and ln will cancel. You'll be left with secant x. Okay, then you're going to multiply through by secant x, so you get y prime secant x plus y secant x tan x equals secant squared x plus 5. Cosine times secant is just 1 because secant is 1 over cosine x. Okay. Then we're going to collapse. So this one isn't so bad. It's just remembering this integral, I think, is the hard part. Anyways, this side will become y times secant x. The right-hand side, just secant squared x plus 5. Integrate both sides. You get y secant x equals, the integral of secant squared is tan plus 5x plus c. and then divide by secant x, or in other words, multiply by cosine. Tan is sine over cosine, so the cosine would cancel there, and you just have sine x, and then plus 5x cosine x, and then plus c cosine x. Whoops, I'm not done. I have to use that initial condition. So phi of 0 is 4. So plug 4 in for y and 0 for x. This part and this part will both be 0, and then you just have c. So apparently c is 4. And your answer, y equals sine x plus 5x cosine x plus 4 cosine x. And that'll be it. So let's take that junk in. Sine x plus 5x cosine x plus 4 cosine x. And drum roll it. Yay. Okay, so that gives you a pretty good idea of what you're up against. So any problem in that list of problems from WebAssign is fair game. Again, if you want more exercises or more work, you could just go through the exercises in the book. It's not a bad idea. I feel like we didn't give you enough homework in these sections, but okay, that's the deal. And as usual, thank you for watching, and I will see you next time.